In this module, we will introduce theoretical approach of probability. We know that as the number of tosses of the coin increases, the experimental probability of getting a head or tail comes closer and closer to the number 1/2. Many persons from different parts of the world have done this kind of experiment and recorded the number of heads that turned up. For example, the 18th century French naturalist Comte de Buffon tossed a coin 4040 times and got 2048 heads. The experimental probability of getting a head in this case was 2048 by 4040, that is 0.507. What will be the experimental probability of a head if the experiment is carried on up to, say, 1 million times or 10 million times and so on? We would intuitively feel that as the number of tosses increases, the experimental probability of a head or a tail seems to be settling down around the number 0.5. That is 1/2, which is what we call the theoretical probability of getting a head. The theoretical probability, also called classical probability of an event E, written as probability of E, is defined as probability of E is equal to number of outcomes favorable to E upon number of all possible outcomes of the experiment, where we assume that the outcomes of the experiment are equally likely. Let us find the probability for some of the events associated with experiments where the equally likely assumption holds. Example: find the probability of getting a head when a coin is tossed once. Also, find the probability of getting a tail. Solution: in the experiment of tossing a coin once, the number of possible outcomes is 2. Head H and tail T. Let E be the event getting a head. The number of outcomes favorable to E, that is, of getting a head, is 1. Therefore, probability of E is equal to probability of head is equal to number of outcomes favorable to E upon number of all possible outcomes is equal to 1/2. Similarly, if F is the event getting a tail, then probability of F is equal to probability of tail is equal to 1/2. Let us take one more example. A bag contains a red ball, a blue ball and a yellow ball, all the balls being of the same size. Kritika takes out a ball from the bag without looking into it. What is the probability that she takes out the 1. Yellow ball, 2. Red ball, 3. Blue ball, 4. Solution: Kritika takes out a ball from the bag without looking into it. So it is equally likely that she takes out any one of them. Let Y be the event. The ball taken out is yellow. B be the event. The ball taken out is blue. And R be the event. The ball taken out is red. Now, the number of possible outcomes is equal to 3. 1. The number of outcomes favorable to the event y is equal to 1. So, probability of y is equal to 1 by 3. Similarly, 2. Probability of r is equal to 1 by 3. And 3. Probability of b is equal to 1 by 3. An event having only one outcome of the experiment is called an elementary event. In this example, all the three events y, b, and r are elementary events. Note that probability of y plus probability of r plus probability of b is equal to 1. This implies that the sum of the probabilities of all the elementary events of an experiment is 1. This is true in general also. Example: suppose we throw a dice once. 1. What is the probability of getting a number greater than 4? 2. What is the probability of getting a number less than or equal to 4? Solution: 1. Let E be the event getting a number greater than 4. The number of possible outcomes is 6. 1, 2, 3, 4, 5, and 6. And the outcomes favorable to E are 5 and 6. Therefore, the number of outcomes favorable to E is 2. So, probability of E is equal to probability of number greater than 4 is equal to 2 by 6 is equal to 1 by 3. 2. Let F be the event getting a number less than or equal to 4. Number of possible outcomes is equal to 6. Outcomes favorable to the event F are 1, 2, 3, and 4. So, the number of outcomes favorable to F is 4. Therefore, probability of F is equal to 4 upon 6 is equal to 2 by 3. Are the events E and F in the example above elementary events? No, they are not, because the event E has 2 outcomes and the event F has 4 outcomes. Here, probability of E plus probability of F is equal to 1 by 3 plus 2 by 3 is equal to 1. Here, E is the event getting a number greater than 4 and F is the event getting a number less than equal to 4. Note that getting a number not greater than 4 is same as getting a number less than or equal to 4 and vice versa. Isn't F same as not E? Yes, it is. We denote the event not E by E bar. So probability of E plus probability of not E is equal to 1, which gives us probability of not E is equal to 1 minus probability of E. The event E representing not E is called the complement of the event E. We also say that E and not E are complementary events.
So our question number 1 is, two customers, Sham and Ekta, are visiting a particular shop in the same week, Tuesday to Saturday. Now this is important, Tuesday to Saturday. Each is equally likely to visit the shop on any day as on another day. What is the probability that both will visit the shop on the same day, second, consecutive days, and the third, different days? So in this question, two customers, Sham and Ekta, they are going to a shop and they can go to the shop on any of the days starting from Tuesday to Saturday, and we have to find the probability that they visit the shop on the same day, consecutive days, and on different days. So first we'll find the probability of visiting the shop on the same day. In the question it is said that both of them, that means our Sham and Ekta, they can visit the shop on any of the days starting from Tuesday to Saturday. So we have the days on which they can go are Tuesday, Wednesday, Thursday, Friday and Saturday. In all there are 5 days. So first customer, Sham, can go to the shop in 5 ways. There are 5 ways in which he can go to the shop. That means he can go on Tuesday, Wednesday, Thursday, Friday, Saturday, on any of these days. So Ekta can go to the shop. She can also go to the shop in 5 ways. That means there are 5 ways. That means she can go on any of the days out of 5 days. So total number of ways in which both can go to the shop is, this is important, whenever we can have one person can do a job in 5 ways, another person can also do the job in 5 ways. So the total number of ways in which both can do the job, that means the total number of ways in which both can go to the shop is 5 into 5, that means 25. So this is the total number of ways in which both can go to the shop. So if both go to the shop on the same day, then possible ways are both are going to the shop on the same day. That means they can both go on Tuesday. So TT. Both can go on Wednesday. WW. Both can go on Thursday. TH. Both can go on Friday. FF. And both can go on Saturday. SS. So these are the ways in which they both can go on the same day. So the total number of ways here is 5. So both can go on the same day in 5 ways. So probability of going on same day is equal to number of favorable outcomes divided by total number of outcomes. Here our number of favorable outcomes is 5 and total number of outcomes we have calculated it to be 25. So this will come out to be 1 by 5. So this is the probability of going on the same day. Our second part is we have to find the probability of going to the shop on consecutive days. So total number of ways in which both can go to the shop is 25. We have done in the previous question. Now ways in which they can go on consecutive days is, our days here are from Tuesday to Saturday. So consecutive days they can go is Tuesday, Wednesday, or Wednesday, Tuesday, Wednesday, Thursday, or Thursday, Wednesday, Thursday, Friday, or Friday, Thursday, Friday, Saturday, or Saturday, Friday. So number of ways for consecutive days, these are 8 in number. So probability of going on consecutive days is equal to number of favorable outcomes divided by total number of outcomes. So number of favorable outcomes here is 8 divided by total number of outcomes is 25. So 8 by 25 is the required probability. So our third part is we have to find the probability of going to the shop on different days. So total number of ways in which both can go to the shop is 25. We have calculated. And number of ways for going on same day. In the previous first part of the question, we have calculated that both can go to the shop on the same day in 5 ways. So number of ways for going on different days will be 25 is total and 5 is for the same day. So number of ways they will go to the shop on different days is 25 minus 5. That will be equal to 20. So probability of going to the shop on different days is equal to number of favorable outcomes divided by total number of outcomes. So number of favorable outcomes here is 20 divided by total number of outcomes is 25. So this will become equal to 4 by 5. So this is our answer. So question number 2 is a die is numbered in such a way that its faces show the numbers 1, 2, 2, 3, 3, 6. It is thrown 2 times and the total score in the 2 throw is noted. Complete the following table which gives few values of the total score on the 2 throws. What is the probability that the total score is even, 6, at least 6? So in this question what is happening is we have a special type of a die which has numbers 1, 2, 2, 3, 3 and 6. Our normal die has numbers 1, 2, 3, 4, 5, 6, but this is a special type of a die. We are throwing 2 dice and then we are calculating the total of the numbers which are appearing on the die. So this is our table. So if 1 and 1 appear on both dice, then our total is 2. If 2 and 1 is there, then the total is 3. In this way, we have some values are there which are already given in the question, and some values, the rest of the values we have to fill. So filling up the tables, here 2 and 1 this will be 3, 3 and 1 this will be 4, 3 and 1 once again this will be 4. Now here 2, 2, 4, 3 and 2, 5, 3 and 2, 5. Now here we'll have 2 and 2, 4, 3 and 2, 5. Now in this column we will have 2 and 3, 5, 3 and 3, 6, 3 and 3 once again 6. In this column we will have 3 and 3, 6, 3 and 3 once again 6. Here we will have 2 and 6, 8, 3 and 6, 9. So now we've filled up the values which were empty in our table. So in our first part, we have to find the probability of the score, total score being even. So we will identify here our even numbers. Even numbers is 2, 4, 4 here, 4, 4, 8, 4, 4, 8, here 4, 6, 6, 4, 6, 6, 8, 8 and 12. So total scores which are even are, if we count them, these are 3, 3, 6, 3, 9, 3, 12, 3, 15 and 3, 18. So probability of even total score is 18 divided by the total number of scores, these are 36. If we count all these scores, these are 36 in number. So our probability of even will be equal to 1 by 2. So in our second part, we have to calculate the probability of the total score being 6. So if we look in our table, let us find out where the total score is 6. So in this column there is no 6. Here we have 2 6, and in this column also there are 2 6s are there. So total number of 6s is 4. So probability of getting a total score of 6 is 4 by 36. 36 is the total number of scores which are there. So this will be equal to 1 by 9. So our third part is we have to find the probability of the total score being at least equal to 6. So whenever we have at least 6, that means we will have totals which are equal to 6 and can be greater than 6 also. So we'll have the total 6, 7, 8, 9 and 12. So let us mark the totals which are equal to 6 or greater than 6. Such totals are 7 here, 8 here, 8 here, 6 here, 6 here, 9 here, 6, 6, 9, 7, 8, 8, 9, 9, 12. So let us count these. These are 6, 3, 9, 3, 12, and 12 and 3, 15. So probability of at least 6 is 15 divided by total number of outcomes, which is 36. So we can cancel this with the table of 3. This will become 5 by 12. This is our required probability. So our question number 3 is, a bag contains 5 red balls and some blue balls. If the probability of drawing a blue ball is double that of a red ball, determine the number of blue balls in the bag. So in this question, we have to find out the number of blue balls in the bag. It is given that we have a bag which consists of 5 red balls and some blue balls. And the number of blue balls we have to find. Also given is probability of drawing out a blue ball is twice the probability of drawing out a red ball. So let the number of blue balls be x. So if number of blue balls is x, then the total number of balls will be 5 plus x. 5 is the number of red balls and x is the number of blue balls. So total number of balls is 5 plus x. Now, probability of drawing out a red ball will be equal to number of red balls divided by total number of balls. So number of red balls is 5. Total number of balls is 5 plus x. Similarly, probability of drawing out a blue ball will be equal to number of blue balls divided by total number of balls, and number of blue balls we have taken to be x divided by total number of balls is 5 plus x. And according to the given condition in the question, probability of blue ball is twice the probability of red ball. So probability of blue ball, that means x divided by 5 plus x is equal to 2 times the probability of red ball, and probability of red ball is 5 divided by 5 plus x. This can get cancelled, and from here our x will be equal to 10. Therefore, number of blue balls in the bag is equal to 10. So question number 4 is, box contains 12 balls out of which x are black. If one ball is drawn at random from the box, what is the probability that it will be a black ball? So first we will solve our part first of the question. In the part first, we have to find the probability of drawing a black ball from a bag. It is given that inside the bag there are 12 balls in total, out of which x are black balls. So probability of drawing a black ball will be equal to number of black balls divided by total number of balls. Number of black balls is x and total number of balls is 12. So probability of drawing out a black ball is x by 12. So our second part of the question is, if 6 more black balls are put in the box now, the probability of drawing a black ball is now double of what it was before. Find x. So in our part second, it is being said that to our box we are adding 6 more black balls. And now the probability, that means after adding 6 more black balls, the probability of drawing out a black ball has become double the probability of drawing a black ball previously. That means the new probability has become double this probability. So we have to find, in second part, we have to find the value of x here. So total number of black balls now, previously our number of black balls was x. So, and now we have added 6 more black balls. So total number of black balls now will be x plus 6. And total number of balls was, previously the total number of balls was 12. So now the number of balls will be 18. So now let us say the probability of drawing a black ball, let it be B1. Probability of B1 will be equal to number of black balls, that is x plus 6 divided by total number of balls, that is 18. And according to the condition, it is said that this probability, that means B1, is twice the probability of drawing a black ball earlier. That means this x by 12. So this implies x plus 6 by 18 is equal to twice of x by 12. So from here we can find the value of x. We can cancel this. This is 6 3 are 18, 6 2 are 12, 2 and 2 will get cancelled. So this implies x plus 6 divided by 3 is equal to x. So this implies x plus 6 is equal to 3x. This implies from here 6 is equal to this x will go to the other side 2x. This implies x is equal to 3. Therefore, number of black balls is equal to 3. So question number 5 is a jar contains 24 marbles. Some are green and others are blue. If a marble is drawn at random from the jar, the probability that it is green is 2 by 3. Find the number of blue marbles in the jar. So in this question, we have to find the number of blue marbles in a jar which contains both green and blue marbles. It is given that total number of marbles is 24. Probability of drawing a green marble is 2 by 3. So let the number of blue marbles be x. So if number of blue marbles is x, then number of green marbles will be total is 24. 24 minus x. X is the number of blue marbles. So this will be the number of green marbles. So now probability of green marble will be equal to number of green marbles divided by total number of marbles. Number of green marbles here is 24 minus x divided by total number of marbles is 24. And it is given that probability of drawing a green marble is 2 by 3. So we can write here 2 by 3. 2 by 3 is equal to 24 minus x divided by 24. This can get cancelled. This is 3 8s. Now this will become 16 is equal to 24 minus x. So this will imply from here our x is equal to 24 minus 16. So this will imply that x is equal to 8. Therefore, number of blue marbles is equal to 8. This is our answer.